right, given 2 points, if we're asked to find the slope. If you want to be real specific here, you could label your points and say, here's x1, here's y1, here's x2, here's y2. And if I know the formula for slope, which is y2 minus y1 over x2 minus x1, I could just plug in accordingly to that formula. So if I do that here, I could say m is, or m equals, I said y2 minus y1, that'd be negative 9 minus 7. And I said that was over x2 minus x1, so x2 would be 4, x1 would be 3. Being very specific to that formula and plugging in accordingly, I get negative 9 minus 7, which is negative 16, over 4 minus 3, which is 1, meaning my slope for this line that passes through those 2 points would be negative 16. Now, if I'm not as specific to the formula, and say I don't go through and I do all this labeling with the x sub 1, y sub 1 stuff, you know, I could have started over here and said, let's take 7, subtract negative 9. But since I started over there with the first point, then for my x's in my denominator, I have to take 3 and subtract 4. Either way, I should find I get negative 16 back. So doing the second one here, you've got a line that passes through the ordered pair of 3, 5, and 3, negative 100. Your slope would be, well, let's say I do start with the first point this time. I'm taking the y value from the first point. I'm subtracting the y value from the second point. I'm putting that over. Now the difference in the x's. As I work from point to point, I started with the first, so be consistent. Take the x value from the first point, subtract the x value from the second point. As it turns out on this one, they are the same values. Meaning, well, let's see, this becomes positive up here, so that's 105. Down here we get 0, so our slope for this line that travels through these 2 points would not exist, right? Usually the name we give this kind of slope is an undefined slope. In fact, the type of line this would represent, if you think about how you graph it out between those points, notice the x values are the same, right? Be passing through 3 for both those x values. This would be a vertical line. So a vertical line would have an undefined slope. Those special lines that we know, vertical lines, horizontal lines, they give us, you know, special scenarios as they play out with the slope concept. All right, this last one, we got a line that passes through the ordered pair of 1/2, negative 1/2, and 3/5 of 9. If I find the slope here, m is going to equal, start with the difference in the y's, so if I work from first point to second, I've got negative 1/2 minus 9 all over. Again, working first point to second with my x's now, it's 1/2 minus 3/5. Okay, you got a mess of fractions going on. No big deal. If you find some common denominators, starting with my my numerator here, common denominator is going to have to be 2, right? So it's negative 1/2 minus. If I'm changing this 9 over 1 to something over 2, well, I multiply my denominator by 2, multiply my numerator by 2, this would be 18 over 2. Common denominator in the denominator. That would have to be 10, right? Because I got 2 and 5 that I'm working with. So this first fraction is something over 10, the second fraction is something over 10. How's this first fraction change? I'd be multiplying by 5 to get this 10, so multiply by 5 up here, get 5. For the second fraction, if I'm getting this 10 back, I'd be multiplying this 5 by 2. So multiply by 2 up here, get 6. Got my common denominators now. Go through and subtract accordingly. I would have negative 1 minus 18 on top being negative 19 over 2. All of that divided by, it'd be 5 minus 6, so negative 1 over 10. If I remember my rules now for dividing here with fractions, bring my work up here since I'm running out of room, I would take my numerator of negative 19 over 2, and I would multiply by the reciprocal of the denominator, which would be negative 10 over 1, or just negative 10. We multiply that out. Got negative times negative positive. Got 19 times 10, which is 190. Got 2 times 1, which is 2. So 190 over 2, I would say that's an acceptable answer here for our slope for that third set of ordered pairs. All right, find the slopes of the lines. Probably best practice to perform here is making sure everything is in slope-intercept form. All right, because once upon a time we've talked about how to graph these. We know if it's in slope-intercept form, we can utilize the slope to help us graph. So if I use y equals mx plus b, that should help. As you look at this first equation for a line, y equals negative x, that's in the mx plus b form, right? So if it's in the mx plus b form, the coefficient on x being negative 1, that would be my slope. Let me skip around here a little bit. We'll come back to these special lines in just a moment. We should know based on the previous slide what these answers are going to be, but we'll come back to them. Let's stick with the theme of the slope-intercept form, though, for a moment as we look at 5x minus 3y equals 9. If I'm sticking with that theme, I'm solving for y. So subtract my 5x over. Got negative 3y equals, it'd be negative 5x plus 9 if I start to rearrange my terms. I'm dividing through by negative 3. Divide by a negative 3 all the way through. You'd have negative 5 divided by negative 3, which is 5/3 x. And then you'd have 9 divided by negative 3, which would be just minus 3. So there's your slope-intercept form. If you take the coefficient on the x from that form, that's your slope. So your slope here is simply 5/3. If that made any kind of sense, then we should be able to do this last one here. If you're a fan of clearing out the fractions, then let's start by taking that common denominator between 2 and 3, which would be 6. Let's multiply that to both sides. As I multiply to both sides, distribute the 6 through, take 2 into 6, get 3. 3 times the 1 on top got 3, so that'd be 3x. Minus, if I distribute through to this particular term, 3 goes into 6, get 2. 2 times the 2 on top, get 4, so it'd be 4y. And that equals over here, 8 times 6, 48. So solving for y. I take my 3x, subtract it over. And if we start to cut to the chase here, right? We could rearrange the terms, but let's kind of do a couple things at once here. I'm going to divide through by that negative 4, right? So I'm going to get y equals, let's divide that x term first. It'd be negative 3 divided by negative 4 would be positive 3/4 x. And then you got this 48, which is positive, divided by that negative 4, that'd be negative 12. So there's your slope-intercept form. If we take our slope now, our slope being the coefficient on the x, our slope would be 3/4. So now we go back to these special scenarios. You got x equals 1, you got y equals 1. Well, we discussed this on the previous slide. X equals 1. We appreciate what that graph looks like. It's a vertical line, right? Any vertical line will have an undefined slope. Sometimes you see it expressed as no slope. Now understand, no slope doesn't mean zero slope. It just means there is no possible slope. Now y equals 1, we recognize that to be a horizontal line. So a horizontal line, want to take any guesses on what the slope is? Any horizontal line, the slope will be 0. That's correct. Okay, now we're going to do a few problems where we know what the slope is. With the given points, we've got a coordinate or coordinates that are missing. So we've got to solve for that missing part of the ordered pairs. Solving for A here on number 1. Knowing the slope is 3/2. Well, if we know what our slope formula is, which is difference in the y's over difference in the x's, I could start by trying to evaluate my slope based on these points. How I would do that, I could take 9 minus a, subtract my y's, right? Put that over. Same order with the points now for the x's. Got to go first to second because that's what I selected on top. So it'd be 4 minus 3. Obviously, I'll have a variable left over. It'd be 9 minus a over 1. But what I could do is I could take this 9 minus a over 1. I know that's supposed to equal my slope. I could set that equal to the given slope of 3/2 to figure out what a is. So bring those two ideas together. If you bring them together, you've got 9 minus a over 1 equal to 3/2. And since I kept it as 9 minus a over 1, I can do a little cross multiplying at this point. Cross multiplying, I have 2 times the quantity of 9 minus a equal to 1 times 3. If I distribute the 2 through, I've got 18 minus 2a equals 3. Subtract your 18 over. 3 minus 18, we get negative 15. Divide by negative 2. Negative 15 divided by negative 2, get positive 15/2. So a is 15/2. All right, we got the same routine. So if we look at number 3 first, let's just go from first ordered pair to second ordered pair again as we set up our slope. Let's take, it'd be 5, my y value from the first ordered pair, minus, now I got to be careful, my y coordinate from the second ordered pair is a minus 2. Since I'm subtracting that, I need to put that down with a little set of parentheses, right? Because that negative will have to carry through. So I've got my y's taken care of from each point. I'm going to put that over. Subtracting my x's, working from first point to second, would be a plus 3, where again I could use parentheses here, but they're not as significant now. It's a plus 3 minus the x value from the second ordered pair, which is 1. If I clean that up a little bit, got to distribute that negative through. That would leave me with, let's see, it'd be 5 plus 2, so 7 minus a in the numerator. Denominator, you've got plus 3 minus 1, so that's plus 2. It'd be a plus 2. All right, like we did on the previous problem now, I'm going to take my expression that I got back for the slope from comparing my 2 ordered pairs. I'm going to set that equal to the given slope on this problem, which is 4. If I list that as 4 over 1, I can do the same trick I did on the previous problem. I'm going to do a little cross multiplying. As I cross multiply, this first diagonal here would be 1 times 7 minus a, so that's just going to be 7 minus a, equals. Second diagonal is going to be 4 times this quantity of a plus 2. Let's distribute some things out. Kind of running out of room here, so I'll bring it up here, carry over this problem. That's 7 minus a equal to 4a plus 8 when I distribute through. I think what I'm going to do is I'm going to go ahead and add this a over to the right. That makes this 5a. And subtract this 8 over to the left. 7 minus 8 get negative 1. Divide by 5 to both sides. A is going to be negative 1/5. Okay, Okay, so back on number 2, if we, all right, if we think about this first, the absolute value. Absolute value, by definition, gives us two things. Right? Potentially it gives us A back, and it's going to be A whenever A is greater than or equal to 0, right? Whenever it's positive or 0. But it could give us negative A back, the opposite of A, if A is less than 0, if A is negative. So if I consult my definition here for absolute value first, and think about the possibilities for what the absolute value of A here could represent, let's try to make some sense out of this as we set up our little slope ratio. We know what the x's are going to be. We know if we go from first point to second point, it would be 3 minus negative 1 for the x's, so that's going to go down there in the basement. We know for the y values, having started with the first point going to the second, that this has to be A here minus, well, I don't want to say absolute value of A because that could mean two things. So let's think of our choices. One of the choices for the absolute value of A would be A, right? So if I let this be A right here, your numerator becomes 0, right? So our slope would be 0. What's our slope supposed to be? Negative 2. So we don't want to choose A. Now if I choose negative A, that leaves me something to work with, right? That still gives me a possibility of figuring out what A could be to get a negative 2 back for a slope. So if I choose negative A, I've set up my ratio now, do some simplifying. It would be A plus A, so 2A, right, over the 4. Have a double negative, switch to positive. 2A over 4 is the same thing as A over 2 if I reduce. So now I got my little setup for a formula for slope. I'm going to take that A over 2, set that equal to the slope that's been given as negative 2. If I put that as negative 2 over 1, just to be consistent with the previous problems we've done. Now I can cross multiply. If I cross multiply, you got A times 1, or A, equal to 2 times negative 2, or negative 4. A would have to be negative 4. Think about how we chose this in the first place, right? We went with this negative A because it gave us something still to work with as a variable so we could solve the problem. But what did A have to be in the first place? A had to be something less than 0. It had to be negative. Notice the answer we came up with. It was a negative 4. How about that?